Before we look at the project template, we'll start by looking at the hardware that we'll be using. So the development board that I'm using is this one, STM8 S103F3 P6 board, and it's the first thing that came up when I searched for STM8 on Amazon. And then for the programming, the one to flash the program onto the board, I'll be using STM32 ST-Link version 2. Okay, we'll start by downloading the project template from GitHub. We can do it using the GitHub CLI command line interface, or if you don't have GitHub installed, you can download the project template as a zip file, unzip it, and then start working with it from there. But we'll just use the command line interface. So git clone. So once that is downloaded, initially we just had linking the folder. So if I look at the directory, I'll see that one is installed, has been downloaded. So if I can do code STM8, I can open Visual Studio like that, just cd into STM8 and then do code from that folder. Okay, so once you get the template, you'll notice that there are different folders within the template, and you'll notice that VS Code has detected that there's a dev container folder and it is prompting you to reopen the project in container. We'll not do that for now. So it noticed this folder, and within it there's this settings file that tells dev containers which image to load and how to run it, and which extensions to install after the image has been run. So currently it's building the image that we're going to use from a Docker file. And if we open that Docker file, so if I open that Docker file, you'll see that we are starting from a base image of Debian Trixie Slim, and then we are adding a user STM8 and installing some packages which will be needed, as well as creating a script, a bash script, and then downloading this repository, cloning that repository, and then eventually we are running that script to install this flashing software. So we are going to use this to flash our programs onto our boards if our host computer is Unix based. But currently we are running this from Windows 11, and we are going to use the ST Visual Programmer to flash the program onto the development board. We'll get to that later. So dev containers is building this image and then running that image as a container and doing other things like installing all these extensions. So if we look at the desktop app for Docker, we'll notice that there are no containers running, there's no images installed, and maybe even volumes, there's nothing. And this is what you'll get the first time you install Docker. Okay, next we have a VS Code folder, and this basically tells VS Code where to search for C and CPP header and source files. We'll be looking for the source files from the app folder, where we'll have our includes and our source files. And we'll also be looking for headers and .c files from the standard peripheral library, which we have in this folder, and that one, and it's going to the libraries folder. So within the libraries folder, you have your include and you have your source files. This standard STM8S standard peripheral library, I just got it from STM website, so you can just search for STM8 standard peripheral library, and it will be one of the first things that you get. So that was you can download it from there if you want the originals. Okay, within that we also have the libraries. We also have project templates and examples, which you can look at to get to know how to use the different peripherals, as well as utilities. So if you need any files from the, for example, if you want to use some template files, then you will need to copy them and put them into this folder, uh, because this one will be only searching for them here. And if you want any other source files, you need to include them here. Okay, and then we have a build folder where all our build files will go into, as well as some make commands. We have a readme which will guide you on if you look at it from the website itself. I'll do some updating on it, but then it will contain some instructions as well as some references that you can use. Okay, so if we look at the make file, there are some make commands that we'll be using to build and to flash our build onto the dev board. Okay, so that's the file structure. We will reopen this in a dev container. So the way to do it is you can click this button and search and click on reopen in container, or you can click Control Shift P to open the command palette and search for dev container reopen in container. Because I've used it before to be there, rebuild and reopen in container. If you click on this, it will reopen it in a container, or you can just click there and then type greater than symbol, then type reopen in container. Okay, so we'll reopen it in container. So what it does is, first of all, it will download the base image. So if we search, it will download the base image and then build on top of that image. So first, we downloaded our base image, then we did all those modifications that we wanted to do, that we defined within the Docker file to create that image. And after that image had been created, we ran it as a container. Okay, so it opened a container and named it optimistic Nobel. Okay, and then started a VS server on it, VS Code server on it, and now we are able to edit files within that dev container as if we were in that container, even though we are still running this from a Windows environment. Okay. Okay, our image is running, and if we do cat, if we look at etc OS release, we'll see that we are running a Debian, and it's the Trixie version, and it has all the things, all those dependencies that we wanted to install. For example, we have tree, so we have that. We have all these dependencies installed, as well as we created this script file. So if I do ls, and if I search within that folder, we'll see that this is that script file we created, and that script file downloaded this repo, made it, installed it, then deleted the file, the folder containing all those source files. And now we have STM8 flash. We can do a listing, and it shows us all the STM8 microcontrollers that we can flash. We can use this tool to flash our programs to. So we have that. Just clear CLS, clear. Okay, the next thing that we want is we look at the program itself. Just to have a quick look. So the program is really simple one, and what we'll be doing is initializing our GPIO pins, of which we are only specifying the LED that's on the board as an output, and then we are also configuring our ADC, and to do that we are using whatever is in channel 1 of the ADC. So to see what pin that one is, we can open STM8 Cube MX to get so that this will help us with pin configurations when working with the standard library. So we are using STM8S series. We are working with S103, and we are using this. It has that microcontroller. Our development board has that microcontroller. So if we select channel 5, we can see that that is connected to D5. So on your microcontroller on your development board will connect it to whatever pin that goes to this one. Okay. If you want to use other peripherals, it will also help you to check out the pins that you're supposed to use. Okay, so our ADC 1 channel 5 is connected to D5. Okay, so after we've configured our ADC, we read it, we multiply it by 60, we cap the value at 5,000, and then we use that as a delay between toggling the LED on and off. Okay, so we'll look at the makefile, and if you're going to use different peripherals, you'll need to change the library sources that you're going to use. Currently, we are only using the GPIO as well as the ADC1 source files. So if you make any changes, if you use any other peripherals, you'll add to these ones or remove. And then we are also specifying the board that you're going to work with. So currently we are using S103, and this value, you can check out the values that you need to specify, and that will be in your STM8 S.H header file. So if I search for that, so instead of defining it here, we are passing it as part of the build instructions. So if you need to specify any other microcontroller, then we are going to change that. Next, when doing flashing, if your host computer is something different, say instead of using Windows, you are using Linux or Mac, then you're going to be using the STM8 flash as command. And to do that, you're going to specify your microcontroller as well as the ST-Link that you're going to use. The supported ones that we looked at were these three. So you'll have to, depending on what you have, choose either the version 1, version 2, or ESP ST-Link, as well as defining your board. So to check out the supported microcontrollers, so the supported ones you can get by running STM8 flash-L. So if I run that, you'll see that it has all the ones that you can specify are listed there. The one that we're using is S103, and it will be picked up by this flag. So instead of a question mark, we'll have our P3 F. We'll have our F3 there. Okay, and that will be all. So after, next we'll need to do the building. To do the building, so if we currently look at the sources, you'll notice that this build file is empty, and because we have access to the folder is shared between our host and our container, we can access the same files that are within this folder. We can access them from our host. So currently there is nothing inside of there. We can run our make all to build our project, and once we do that, then everything will be pushed out into that folder. Then we'll have access to that as well from our host. Because we are using Windows, we are going to flash our program using STVP or ST Visual Programmer. So if I just open that, okay. So if I open Device Manager and connect, so you'll notice connect my version 2 STM32 ST-Link. So that's connected. Next, we are going to open the binary that we want to flash. We'll open the folder that contains the binary, and we'll load it. We'll just check whether write protection is on. It's off. So that's off. Next, I can flash my binary onto the board, and that will be successful. So that's how you will do it on Windows. If you are using a Unix based system like Linux, then what you can do is from the command line interface, you can do make flash. And if your board is connected, then it will flash it flash your binaries onto your board. If your board has been locked, then you can do make flash unlock, and that will flash your program, will unlock your board or microcontroller, unlock your microcontroller, then flash the program onto your board. If you like this, then give the project a star. So looking at the images, you'll notice that the image that we are currently using is taking up 503 megabytes of memory. Sometimes if you're using the same image, if you want to use the same image to run on different projects, say you're working on 3 projects that are all STM8 based, and you want to use the same image on each of those, you may not want to have a separate image for each project. So what you can do is, I'll just reopen this locally. So instead of building and running that image from the Docker file, you can create a local image and run from that. So if I reopen this in dev container now, it will search for this image, of which it won't find it from this list, or it will also try to look for the same from the online sources of images, Docker images, and it won't find it, and it will bring an error. What I can do is that I can build a new local image and then name it, give it the same name that I want to use. And once I've built that, we'll be able to run that. So let me do that. So we are in this folder, and we are going to run this, and it's going to look for a Docker file within this folder. That's where our Docker file is. So our Docker file is there. So if I run this, it's going to build that image, and you're going to have that image over there. Okay. So now I can delete this. I can have it or delete it. I'll just delete it. And now if I do reopen in container, and you don't have to do this, just to show you, just in case you use the template on various things. So reopen in container, it's going to use that image. Okay. See you in the next one. Bye.